quick video today on electrical fault finding in electrical maintenance engineering. One thing that I keep seeing over and over and over again with the new technicians coming through, apprentices, the sort of inability to do the basics well. So I'm going to go through step by step how to check with the meter first, and then moving on to the installation resistance. Okay, so here's a motor. This is off a test bench, so the cables are already removed, the earth's removed. So what we have here is a motor in delta configuration, and you've got U1, V1, W1, you've got W2, U2, V2. Okay, so the first thing we need to do is to remove our links. Okay, so this, to be honest, is the part that most people are okay with and they check. So you're checking the resistance between phases. Now this should probably be done with a multimeter, but we're going to do it with a clamp meter. The resistance should be pretty low. What you're looking for is for it to be consistent across phases. So U1, U2. I'm just trying to, you want to make sure you've got a really solid contact on both. So that was 12.5-ish. V1, V2. Again, make sure you've got a really solid contact. And W1, W2. And you can see there the difference between the contact. So that's quite loose. You can see that that's a little bit loose there. If I go on the top, you can see that that's 13.6. If I actually do it on the coil, the winding wire, sorry, 12.4. So you can see that that can actually change and influence things quite a lot if that's not tight down. So obviously we want to make sure these are tight, but for demonstration purposes, obviously it doesn't matter too much. So at that point, you can check down to earth if you would like to on continuity, and normally people just leave it there and they say, yeah, that's fine, it's got very even distribution across, it's got 12.5 ohms across the whole 3 phases. It's not down to earth perfect. However, it doesn't tell the whole story, and I've seen it where people then put these motors back on and they don't work, because the next stage of this is to do an insulation resistance test. Okay, so when we're testing insulation resistance, we're going to test from each winding to earth, and that will give us an indication. So what we're looking for here really is on here we have this at 500 volts, 200 mega ohm. So when we test, we're looking for greater than 200 mega ohm, which means that it has really good insulation resistance. What we do is we just test. And so 1 on here means that that is greater than 200 mega ohms. So that's great. So that winding. So we test, let it stabilize. And now. Again, insulation resistance is greater than 200 mega ohm. Let's do this one. Greater than 200 mega ohm. Okay, and if we go from across the windings, yeah, so let's do that one again. Okay, again, and then we'll just check these. Stabilize. So in all accounts, that motor is okay. So that's how it's done.